My name is Alex Raymond. I am the director of the Center for Integrative Genomics, and we are part of the University of Lausanne Faculty of Biology and Medicine. So I did biochemistry and biology at university, again in Lausanne, and then I did my thesis, my PhD, at the Swiss Institute of Experimental Cancer Research. And then I went for a postdoc to Harvard Medical School. I had my first lab in Italy at the Teleton Institute of Genetic Medicine. And then I was really fully, not in genetics, but in human genetics. And from there, I went back to Switzerland, University of Geneva, at the Department of Medical Genetics, or now Department of Genetic Medicine. And before joining, as said, the Center for Integrative Genomics in 2004, as a tenure track as a professor, and went up the different ranks, associate, full professor, and now the director. I am also a passionate bird watcher and mammal watcher. So nature and the changes and the different facets of nature have always been quite appealing. And I think that to understand how it works was just a natural step. And so you can ask the question, so why from a total organism, a full organism, let's say, why you didn't do zoology? And I saw that at least at the time now, genetics is providing the tool for the zoologists they didn't have at the time. But at the time it saw that it was more intellectually challenging to move to genetics, still having the passion on the side as a passion. I did quite a bit of work on the genetics of intellectual disability. And so this immediately has a link with the brain. And I have here to mention that intellectual disability was a bit not a mystery, but there was a paradox. Because you say, on an evolutionary paradox, because if intellectual disability makes that your fitness, you will have less children, it should disappear. While it's always constant in the population, and this is because we solved the paradox. Now we know is that because when we prepare gametes, each of us at some level will have gametes with a mutation which can cause intellectual disability. And this is really frequent because a lot of genes are important for the function of brain and cognition. And so there is a lot of mutation that can impact basically the proper functioning and ending up in intellectual disability. So that's a link. So like intellectual disability, autism spectrum disorder, for example, those are probably, we are grouping those patients in one group. But probably there are different patients with different disease, each with, problem at the level of sociality, but maybe with different aspects, which at the moment we don't have really a way of differentiating. If we can understand the etiology, and some of the etiology will be genetical, other ones will be environmental, or a combination of both, but if at least we understand as a starting point the genetic one, we may be able to create different groups and different bins of patients or group of patients which are, there is one cause, there is one etiology, and then we will be more able to understand those differences and what is making this group of patients different from these other ones. And maybe this also is basically giving us the first hint about what is not going properly or functioning properly because that gene is affected. So there's two different ways. One way is you can have variants, usually common variants. They are in the population, and they will have a small effect on, let's say, cognition or schizophrenia. And big studies have been made. They are called genome-wide associated studies, where you try to basically put together or associate one position on the genome and one variant there with a phenotype. When this work is done, you can go back to any individual, in particular patient, and try to understand and count the number of bad alleles. So, because there is a good situation that decreases the risk, one which is increasing the risk, so you can count how many are increasing the risk. And that's one way to stratify your patient. This is for common variants with little effect. Then there is rare variants, and they are rare because if they have a big effect, they have to be rare because, as said, on an evolutionary point of view, those individuals will tend to have less children than you and me. And so for those, you will have to go not only to genotype and so look at some position on the genome, you will have to look at all the positions on the genome. And so it's a detailed approach or a full genome approach. But the common goal is still to understand why is this patient having one particular phenotype. I think we are, of course, we're bringing, a new angle. But this, if it allows, as said before, to really begin to understand why this patient is different from that one, maybe it's a step in the right direction. And if we can do this, we will for sure being perceived well, because we will have facilitated the work of psychologists, the psychiatrist, and the neurologist. Challenging but fun. I think that's also part why we are doing this job. I think it's ever changing. Technology is advancing. We are able to ask new questions, and so it's always moving, and challenging but fun.